Hi, I'm Caitlin Oglesby, and I'll be talking to you guys about the seasonal flu vaccine. So the flu is very familiar to us, but I'll also cover some of the basics here anyway. Influenza, or the flu, is a contagious respiratory illness that spreads in droplets from things like coughing, sneezing, or talking. And there are a few different types of flus, such as pandemic, seasonal, avian, and swine, but I'll be mostly talking about seasonal flu. So the flu season occurs in the winter months when low temperature and humidity favor transmission. And this seems sort of self-evident, but I don't always consider it. There are actually two flu seasons every year. There's one in the northern hemisphere and then one in the southern hemisphere, and they mirror each other. Also, more tropical regions don't follow the same trends as do the temperate ones, so their flu patterns are much more diverse. Some common flu symptoms include fever or chills, cough, sore throat, runny or stuffy nose, muscle or body aches, headaches, fatigue, and vomiting or diarrhea. And while patients can experience any combination of these symptoms, vomiting or diarrhea are more common in children. And now why the flu is so familiar to us. It's extremely common. The flu affects about 8% of the US population annually, which is roughly 9 to 45 million illnesses a year. Of those, 140 to 810,000 are hospitalized, and 12 to 61,000 die. Worldwide, there's an estimated 500,000 flu-associated deaths every year. So, what causes the flu? There are 4 types of influenza viruses, A, B, C, and D. I'll be talking about influenzas A and B because they cause the seasonal flu, but C is known to cause more mild symptoms, and D is known to circulate in cattle. So influenza A viruses can be divided into their subtypes based on 2 of their surface proteins. There's hemagglutinin, which can be labeled H1 through H18, and neuraminidase, which can be labeled N1 through N11. In this image on the right, the smaller, more narrow proteins are the hemagglutinin, and the broader, a little darker proteins are neuraminidase. There are at least 131 A subtype combinations found in nature, but currently we know of 2 that circulate in humans, and those are H1N1 and H3N2. And then influenza B viruses are categorized based on their lineages. So you can have B Yamagata or B Victoria. And as a side note, influenza B viruses usually change less rapidly than do the A viruses. For some general virus history, this is a timeline of influenza A outbreaks. And while this only shows A, the influenza B viruses are known to co-circulate with A. So just keep that in mind. Before 1918, we don't really have any data because it's too hard to trace the different strains prior to this period. But in 1918, there was an H1N1 pandemic that caused over 40 million deaths. In 1957, there was an H2N2 pandemic. In 1968, there was an H3N2 pandemic. And in 2009, there was an H1N1 pandemic again. And the reason that there could be 2 different H1N1 pandemics was because they're actually very antigenically dissimilar. Also, there was an outbreak in 1977 that just caused a seasonal flu and not a pandemic because it was similar to the 1957 antigen. So now vaccine history. The causative agent was first identified as a virus in the 1930s, and then during World War II, the US tried to produce a vaccine, and they were successful in 1945, when the first inactivated virus vaccine for US civilians was released. Then in 2003, we had our first live attenuated virus vaccine, and in 2013, the FDA licensed a trivalent recombinant vaccine and approved an adjuvanted vaccine. And I'll talk more in depth about adjuvants later, but they're an addition to the vaccine that boosts the immune response. So why is vaccination important? Vaccines are by far the most effective way to prevent the flu. In the 2019 to 20 flu season alone, vaccination prevented an estimated 7.5 million illnesses. While people can be treated with antiviral drugs after they've contracted the flu, that the prevention is still much preferred, especially because of emerging drug resistance in different strains. Vaccines also reduce illness severity. So again, in the 2019 to 20 flu season, vaccination reduced the number of hospitalizations by an estimated 105,000. Vaccination can also be life-saving for children. So there was a study conducted over the 2010 to 14 flu seasons, and the results showed that vaccination reduced the number of pediatric flu-associated deaths by 65% in healthy children and 51% in children with underlying conditions. Vaccines also protect high-risk groups like those over 65, pregnant women, people with certain conditions like asthma and diabetes, those with HIV or AIDS, cancer, and also very young children. So there are a plethora of flu vaccine options, but I'm going to do my best to show you how to differentiate between them. So there are two main flu vaccine categories. There are the quadrivalents, which are most flu vaccines you'll encounter. They protect against 4 flu viruses. There are 2 A viruses, so H1N1 and H3N2, and also 2 B viruses. Then the trivalent vaccines are normally high dose or adjuvanted, and they protect against 3 flu viruses. Again, the 2 A viruses and just 1 B virus. And vaccines can also be differentiated based on their nature and production. So there are inactivated influenza vaccines, which can be egg-based, where the virus is grown in an embryonic chicken egg and then inactivated using an alkylating agent. And they're also cell-based, where the virus is grown in a cell culture to create a candidate vaccine virus, which is then inoculated in mammalian cells before it's purified. And cell-based actually eliminate the possibility of eggs becoming a limiting resource, and they're faster to produce than the egg-based vaccines. There are also recombinant influenza vaccines, which do not require the candidate vaccine virus, and they're also faster than both egg and cell-based vaccine production. Finally, there are live attenuated influenza vaccines, which are egg-based and the only intranasally administered flu vaccine. All the others are intramuscularly injected, which you can see over here. I'm sure everyone here has had a flu vaccine before. It goes in your arm. So, as I said, there are many vaccine options, and the CDC recommends annual vaccinations for people 6 months and older. But the different vaccine options have different age demographics. So the standard dose vaccine is egg-based and inactivated, and it's meant for those 6 months and older. There's also a cell-based vaccine, which is also an inactivated virus, and it's for those 4 years and older. There's a recombinant vaccine, which is meant for those 18 and older. There's a quadrivalent with an adjuvant, which I'll talk more about that a little later, but these are for those who are 65 and older. And I believe the first quadrivalent with an adjuvant was just released in the 2020-21 flu season. There are also high-dose vaccines for those who are 65 and older, and there are live attenuated virus vaccines for those between 2 and 49 years of age. These, as I said, are the only intranasally administered vaccines, and they are not meant for those who are pregnant or immunocompromised. And then finally, trivalent vaccines. So there are some standard dose trivalent vaccines, but more commonly they're associated with adjuvants. And adjuvants are a component that's added to the vaccine to enhance the host's ability to recognize and respond to the antigen. Some examples are alum, MF59, and AS03. So alum was the first, and it's more common, and it is an insoluble complex, and MF59 and AS03 are both oil and water emulsions. So the way an adjuvant works is often a problem with injection is that the soluble antigen just gets cleansed by the lymphatics before an immune response is stimulated. So what the adjuvant does is the antigen gets attached to the adjuvant, and when it's injected, it's either insoluble as alum or it's the oil and water emulsion of MF59 or ASO3. And what they do is just help retention of the antigen in the injection site to allow an immune response to be stimulated. They're also known to recruit cells to the injection site, promote dendritic cell maturation, and they upregulate MHC2 and CD86 expressed in other antigen-presenting cells like monocytes and macrophages. And these are most of my sources that I used for this presentation. So thank you guys for your time, and please get vaccinated for the flu. It helps everybody.